Hi guys, welcome back. In this short video we're going to talk about formatting output. Alright, in a previous video I showed you how to use the cout object to display basically raw output to the screen. Right? Well, what if you want to make it a little prettier, right? Let's say you only wanted to display 2 decimal places instead of 4. Right? Well, in this video I'll show you how to do that. Okay, we're going to make use of these things called string manipulators. Okay, and when we use them, we can use them to format output that control how numeric data and string data are displayed. Right? We can control the size of the output. We can control the position. We can control the number of digits. Okay, so taking a look at my main.cpp file here, we can see #include IOStream. We should be familiar with this right now. That gives us access to cin and cout objects. They're not operators, they're objects. Okay, and then so cout is what we use to display stuff to the screen. Okay, so in order to format it, what we're going to use is we're going to use string manipulators that are available in the iomanip file. Okay, so we need to do #include iomanip, and this gives us access to these string manipulators. Okay. Okay, so let me tell you a little bit about a little terminology here. When we're dealing with output, a lot of times we're talking about fields. Okay, what are output fields? Okay, so let me show you what I mean when I talk about a field. Okay. So let's say that I have these variables, double x and y, and let's set x to, I don't know, 1.5234. Right? I'm just pulling that number out of my backside, and let's set y to 8.6432. Okay, and now let's do a simple cout statement to display. Okay, with a space in between. All right. So with this cout statement, what I have here is I have 3 fields. Okay, x has a value that's going to occupy the first field. The space here is the second field, and y is going to be the third field. Okay, so these string manipulators we're going to use are going to be used to control how these fields are going to look. Okay, how they're displayed. Okay, and some of these string manipulators are only going to affect the very next value that's displayed. For example, we have this setw manipulator. Okay, and so what setw does, okay, setw will print in a field at least x spaces wide. Right, so we'll be able to control with setw x here. What we're going to do, let's say that I did setw 10. That means that the field, the very next field, is going to be at least 10 spaces wide. Okay, so let me give you an example of that. Let me show you what an unformatted string is going to look like here. Okay, let's build and run it. Okay, there's just the one space in between, and there's the values. Okay, so now let me put this setw manipulator here. Okay, okay. So let's put that in here, setw, and we'll make the field 10 characters wide. Let's add another one, setw 10. Make this 10 characters wide, and we'll make the third field also 10 characters wide. Okay, so let me show you what this looks like. Okay, see now everything's spaced out. Okay, there's still 3 fields. But what's going on is that basically there's going to be 10 spaces for each field. Okay, and if the characters don't, or the number doesn't fill the entire 10 characters, then it's padded with spaces. Okay, so this is how we can set things out, or space things out, and arrange data in a more tabular way, I guess you could say. Okay. So let's say that I wanted to do a table of values. Right? Let's say I wanted to make a table. Okay, so let me add some more values here. Okay, A, B, C, D, E, F. Okay, we'll make a 2 by 3 table. Okay, so A equals 5.2, B equals 6.7, C equals 9.9, just random numbers. D set to 1.0, E set to 6.6, and F set to 3.2. Okay, so let me get rid of this stuff, get this out of the way. Okay, and we'll write a cout statement now that arranges this in a nice tabular format. Okay, so let's do that. We'll make it 10 characters wide again. Okay, and we'll have A be first, and then we'll do B, and then we'll do C. Okay, and then we'll have an end line here, so that way the cursor goes to the next line. Okay, and set with 10 characters. D set with 10 characters, E, and finally set with 10. F. Okay. Alright. So let me show you now what this is going to look like. Right? What we're going to see is the characters arranged basically what it's going to resemble a 2 by 3 table, a table with 2 rows and 3 columns. Okay. So there we go. Okay. So I've now arranged this output, and spaced it in a controlled way. Okay. So that's the set with manipulator. The thing to keep in mind is that the value inside the parentheses is how many characters wide the field is going to be, and you have to set that field for each value. Okay. All right. If the value that you're trying to print in that field is wider than 10 spaces in this case, then it's going to add more spaces if it's not wide enough. Okay. All right. So keep that in mind. All right. Okay. But there are some values or some string manipulators that are going to affect all of the values that come after them until you change them again. Right. So there are 3 that we'll consider that you'll see in homework assignments: fixed, setprecision, and Showpoint. Okay, so let me give you a summary, and then I'll give you examples of how you can use them. Okay, so fixed is a manipulator that you use if you want to use decimal notation for floating point values. Okay, setprecision, when you use it with the fixed manipulator, okay, it's going to print the decimal places so many digits after the decimal, okay, and you'll be able to set that. Okay, without it, then we use this thing known as significant digits. Okay, so if you don't use the fixed manipulator, then you're going to start counting the digits that you are going to display from the leftmost number. Okay, in the number, the leftmost digit in the number. With fixed, you start that counting at the decimal place. Okay, I think it'll be a little more clear when I show you examples. Okay, but if you don't have that fixed manipulator, setprecision is going to act wonky for you. Okay, it makes sense when you understand how it works, but a lot of people just assume that setprecision means show me so many places after the decimal point. Well, that only happens if you use the fixed manipulator. If you don't, then it starts printing digits from the leftmost, or what's known as the most significant digit in the number. Okay. All right. Then the final one is Showpoint, which is going to force cout to always print decimal for floating. Always print the decimal point for floating point values. Okay. All right. All right. So let me show you an example of that. Okay. So let me just get rid of all this stuff, get it out of our way. Okay. And then I'll set x to 1.2594 6, 8, 3. Okay, and we'll only need x for this example. Okay, so let me show you what the raw data looks like, and then we'll start using some manipulators here. All right. Okay. All right. Oops. So by default, you're only going to see so many numbers, right? You're not going to print out every single decimal place. Okay. See, this is this number has more decimal places than the default will show, so it's going to round off this last digit here, right? So by default, you can only print 6 digits from a number in a field. Okay, so there's only one field in this thing, and there's 6 digits here, right? So the most significant digit is the 1, right? So let's use some of these manipulators to fix this. Okay. All right. Oh well, let me show you the fixed manipulator first. Okay. And set precision. All right. So let's say that I use the set precision manipulator. Okay. And I set it to 3. Okay. I can put it before the x in a separate cout statement, or I could also put it in here. Oops. Right. Doesn't matter. Any value that's sent to cout after set precision is used is going to have that manipulator applied to it. Right. So I can do it in its own cout statement, or I can do it in a cout statement with the rest of the values that I want to manipulate. All right. So for this example, I'll just put it in its own cout statement. Okay. So let's see how x changes now. Right. So a lot of people will think, oh, well, it's going to print 1.259. Well, no, that's not what's going to happen. Okay, 1.26. Why? I don't have the fixed manipulator here, so I'm going to display the 3 most significant digits. And what that means is that I'm going to display the 3 digits that start from the furthest left digit. So 1, 2, 5, rounded up to 6. Okay, rounds off. All right. So what if I want to display 1.259? Well, that's where the fixed manipulator comes into it. Okay. So let's put that in there, and now let's take a look. Okay, there we go. 1.259. Okay, and it's also rounding here too, right? It's just that 4 causes the 9 to round down. Right? It's not rounded up, so it stays at 9. Okay, so all right. So the last manipulator I wanted to show you was the Showpoint manipulator. Okay, so let's say that I wanted to assign the value 1 to y. Okay. Since y is a double data type and it stores floating point numbers, that 1 is going to be stored as 1.0. Okay. But let's see what happens if I do a cout. Okay. Cout y. Okay. What do you think is going to happen? Is it going to display 1.0 like you would think, since it's a floating point number, or at least it's stored as a floating point number? No, that's not what's going to happen. Okay, cout truncates the point whatever because there's no decimal places after it. Well, what if I want to display 1.0? Okay, well that's where Showpoint comes in to it. Okay, so if I was to do this, if I was to add the Showpoint manipulator, Showpoint, right? Then I'm going to see 1.0000 whatever. Okay. By default, again, remember it's going to show 6 digits by default. That's why there's 5 zeros here, and in addition to the 1, right? Because the field will show 6 digits by default. Okay. And the last thing I will show you is that Showpoint is kind of built into set precision and fixed here. Right? If you use set precision, then you're going to get this Showpoint behavior. Okay. Cout. So let's do a cout y to show you how y is going to change, how the appearance of y is going to change, right? What we're going to see now is we're going to see at the very end, we're going to see 1.000 instead, right? Because we've set the precision to 3 decimal places after the decimal point, okay? That's what fixed and set precision do. Okay? All right. So you can also notice here that I didn't have to set precision for each individual field, right? Both x and y had this single set precision and fixed manipulator applied to them, right? These stay set until you change them, all right? Okay, so the important thing to note here, and I want to underscore this, is that we're only changing the way these values are displayed to the screen, okay? When I compile this, the only thing that's happening is, well, these values are still getting stored in x and y, right? They're not changing. Inside y, there's 1. Inside x, there's 1.2594683. Okay, those values do not change because of what we're doing. Okay, all that we're changing is how they are displayed to the screen. Okay, think of these manipulators as a filter that can change their appearance. Okay, they don't actually change the original values. Okay, so after these cout statements, right, x and y still contain the same value. It's just that they appear different in our output. We're telling cout to display them differently. We're controlling how they're displayed. That's it. We're not modifying the original values. Okay. All right. So I think that's everything I wanted to talk about in this short video about formatting output. Just how to use these 3 or 4 I/O manipulators. Right. We use setw, which is setw, right, to modify the size of the fields. We used Showpoint to ensure that y, when we did a cout on y, that the decimal point was actually displayed. And we used set precision and fixed to control how many decimal places are displayed. And without fixed, we used set precision just to display the 3 most significant digits in this case, right? We could use anything inside as an argument inside set precision. It doesn't have to be 3. It's just for this example, that's what I chose to do. Okay. So there are other I/O manipulators, and I'll just mention them briefly. Table 312 in the book shows you a couple more. There's the left and right manipulator in addition to the 4 that we've seen so far, and what they do is just change justification, right, within the field. Okay, so left will have the justification be to the left side of the field. Right makes it go to the right. Okay, so let me show you. I'll give you an example of that too. Okay. All right, so let's do set width here, and let's just make it 10 spaces. Okay, and let's do set width 10 spaces here. Okay, but let's put them all on the same line. Make this the same statement. Okay, so let's test that. See what that looks like. Okay, so let me get rid of this extra y statement here. Okay, all right. So here we go. These are right justified. Okay, the field starts at the far left. There's 10 characters in it, right, in each field, and these things are right justified by default. Okay, what if I want to make them left justified? Okay, well, let's try to do it for this first field. Okay, all right. So actually, it looks like once you set left, okay, both field it stays set just like with set precision. So both fields following it are now left justified. Okay, that's what that means. Okay. What if I want this first field to be left justified and this second field to be right justified? Well, let me show you what that looks like. All right. So there we go. Okay. So y was right justified again, and x is left justified. Okay. if I do this, let's see what happens. Okay, back to left justify. All right. So you can repeat them if you want to. The left or the justification manipulators, the set precision and fix manipulators, but once they're set, they're set. Okay, it's only set width that you have to repeat for each field. All right. Okay, so I hope that this video was helpful. As always, if you have any questions, feel free to shoot me an email or stop by my office hours. Okay, great. Thanks for watching, and we'll see you next time.